Okay, number 63, we're being asked to come up with an approximation for 64.1 to the 1/3 power. So first thing we got to do is come up with a function right here, f of x, and it looks like we're taking some number here, albeit an ugly number, to the 1/3 power. So that's going to be an x to the 1/3, and we need an a value going along with that, something that's very close to 64.1 and is easily evaluated in this function. So pretty clearly, I think we're going to choose 64, which is the perfect cube closest to 64.1. Okay, so we need to come up with the value of f of a and also the value of f prime of a. So let's do the easy part first. F of 64 is going to ask us to take 64 to the 1/3 power, which is the cube root of 64, and that's going to be a 4. So our point of tangency here is 64, 4. Got it. Next thing we need is the slope of the tangent. So to do that first, we need to find our general derivative, f prime of x. So I'm looking right here, and that derivative is going to be a 1/3 x to the negative 2/3. So I'll go ahead and make it like this, a 1/3, and then x to the negative 2/3 becomes an x to the positive 2/3 on the bottom. And I'll just leave it like that. We now need f prime at our a value here of 64. So that's going to be a 1/3 times, and that's a 64 to the 2/3 power. So what does that do for us here? 1/3 times. All right, guys, 64 to the 2/3. What that means is we would take the cube root of 64 first, which is 4, and then square that number, which is going to get us 16. That looks like a decimal point. All right, instead that's multiplication, so 1/48, and that is the slope of our tangent. So we know our point of tangency. We know the slope of the tangent. We're going to go to point-slope form now to get the equation of our tangent, and we'll eventually get L of x from that. So that's going to be y minus your y coordinate of 4 equals your slope, 1/48, times your x value right here, and then x minus your x coordinate of 64, and that's where we're at. So now we're going to try to solve that for y. We're going to distribute that 1/48 right there. So a y minus 4 is going to equal a 1/48 x minus, and let's see guys, a 64 over 48. They can both be divided by 16. That's going to get you a 4/3, I believe. And then we'll add the 4 on the other side. Let me scroll this guy a little bit right here. There we go. Come on. There we go. All right, so we're going to end up now with a y is equal to a 1/48 x, and let's see here, everybody, we'd be adding a 4, which means we're adding over 3. That's going to be a 12/3 right there would be the best way to do it, so that we can easily combine those two terms there and get a plus 8/3 at the end of all that. And again, usually we call that L of x and not y, so there it is. And now the big takeaway on this problem right here is that if we wanted to evaluate f at 64.1, that was the weird value here, that is going to be very close to the value we get by putting 64.1 into this linear function right here. Okay, so that's kind of the key here. So what are we doing here, guys? Oh, this is still ugly. This now becomes a 1/48 times 64.1. So 64.1 over 48 plus 8/3. And again, I think I'm just going to go to the calculator and do all this as a decimal here. So let's see what we've got here, everybody. We've got a 64.1 over 48. Gotcha. Let me get out of that fraction right now, and we're going to add, shoot, I forgot, was it a 3/8? Nope, 8/3. Glad I checked. 8/3. Okay, and we come up with an answer of 4.002. So let me go ahead and write that down, and that should be the answer right here. But again, if I wanted to double check this and make sure I was pretty close right here, I would go ahead and just grab my calculator and actually evaluate this expression right here, 64.1 to the 1/3 power. So let's try that. 64.1 raised to a power of 1/3, and that's going to get us, yep, something really, really close to that. So I feel pretty good about that answer, and that is that problem.